So question 2 in this paper focuses on the use of microscopes, in particular light microscopes, to look at onion cells under a microscope. This is our field of view, so this is everything you could see through the microscope on that hole in the slide, and on the stage, and then you have your magnification here. We have some apparatus that's provided to us. We have our light microscope, we have a transparent ruler, and we have some prepared slide of onion cells. And the question asks us, it's quite a tricky one, I've not seen it like this before, but it asks us to describe how the student could use the apparatus to estimate the mean length of the onion cells on the slide. So the first thing to do when we go about this is to figure out how big our field of view is. So we get that circular view shown on the previous page. We need to know what's the distance in millimetres from here to here. So if we go back to this, the first thing to do is to place the ruler on the stage. And once we've done that, we could focus on the ruler. That will allow us to measure the width of the field of view. So again, we'd focus on this, and then we'd see a really magnified part of your ruler, and then you could use that to work out the number of millimetres from here to here. Obviously in millimetres, so I should have put that. Replace the ruler with the slides. So make sure we can actually see that. So replace the ruler with the slide so you can actually see the cells you're interested in. You would focus on the cells. Then obviously using the same magnification as you were looking at your ruler with. It would be a case of counting the number of cells that fit across the field of view. So in the example on the previous page, you simply count, well, it's 1, 2, 3 cells that fit across that field of view. You would then divide the size of the field of view obviously in millimetres. So divide the size of the field of view by the number of cells that fit, and that will give you your mean cell length. So again, just to reiterate, it's a case of measuring how big that field of view is, how big a gap can you see through your microscope, counting the number of cells that fits into that, and then dividing that size of gap by the number of cells. It's also worth noting that you'd need to do all the normal things you do when you're using a microscope. You'd focus using the lower power objective lens first. You'd obviously then use the focusing knob. Both coarse then fine. You'd focus at 100 or times 100 magnification. And then you could even use the size of the real cell equals image size divided by magnification to confirm that as well.